EnterCalc 3D has the ability to perform reinforced concrete column design, and to demonstrate, we'll use this single bay, single story reinforced concrete model, and specifically we'll take a look at this column in the background that's highlighted. Now, to keep the video as relevant as possible, we won't go through all the modeling steps required, but I do want to point out that the prerequisite for using concrete design is that we have analysis results. So that implies that every member in the model must have sections and materials. The model has to be stable, and we have to have some loads applied. And we can see that those have all been done already. The one thing that I do want to go into a little bit of detail on is load combinations. Within the load combinations table, we start with the default load combination, and that would always be set to run. That's just a program requirement. Then we can see that I have a few load combinations that I've created just for experiment purposes, but those are set to no, so they aren't even having an effect on the model. The first load combination that's of any significance is this sustained load combo. And I've created that to help the program calculate the values of beta D used in concrete column design. I'll double click this one to pop it open and show that I've used this load combination to define what I feel is a fair representation of the sustained loads on this column. I've set this up to say 100% of the dead load and 15% of the live load can be considered as sustained loads. And then down here in the sustained load factor column or input field, I've used some engineering judgment and gone off to the side, and I've done some calculation to determine what I think is a fair load combination factor to apply to the sustained loads. I'll click cancel because I don't intend to change any of this, and we will come back and see the sustained load incorporated into the column design in a minute. For now, I just want to point out that it is set to analyze or to run. Below the sustained load combination, we can see that we've used the ACI generated load combinations, and what's of significance here is that they're all set to yes in the run column. They're all set to yes in the P delta column so that we get a P delta analysis. And also they're all set to yes in the concrete design column. So they'll all be used for our concrete design. I'm not going to change anything, so I'll click cancel. The next thing that we notice is that our model is currently not solved. We can make sure that we have current analysis results from the analysis tab and then static analysis, and in a second it's done and we have a solved model with complete results. So the rest of our work will focus on the concrete design tab, and I'll just expand this window so we can take a closer look. We'll look at each of these items from left to right. The RC materials button allows us to assign materials. In this case, notice that the materials that we see listed don't include stiffness properties like modulus of elasticity, but instead they include or indicate strength properties. So the concrete material that has been assigned to this one column includes strength of concrete, strength of the longitudinal bars, and strength of the stirrups, or ties in this case. So no work to be done. I've already made that assignment. I can click cancel. The next button is RC Model Design Criteria. The first thing we see here is which code do we want to use. And then beneath that, we have an entire section dedicated to concrete column design parameters, which is what we'll focus on. The other areas off to the right we'll neglect for now. They have to do with beam design and slab and plate design. So within column design parameters, notice that we have the minimum and maximum reinforcing ratio. Then we have some parameters that control the iteration and the design of the concrete sections. And then we have some user options like, do we want to include or exclude the concrete that's displaced by the steel, or do we want to ignore the compressive force in the concrete shear capacity calculation, and so on. The one that's really of significance, though, is this one, sustained load for computing beta D in columns. And notice that I've preset this to that sustained load combination, number 5. So this is where you make the connection between the one that you define over on the analysis side and the design module itself. So I don't want to make any changes here. I'm just going to click cancel. And then we'll come to RC design criteria. There's a beam, column, and a plate design criteria. We'll focus on column. We can create as many column design criteria as we need to. In this case, we're only designing one column, so I only needed one criteria. We can name it whatever we want, indicate whether it's subject to sway in the X and Y directions. We can specify an unbraced length about the X and Y axes, or use 0, and the program will consider the analytical length as the unbraced length. There are K-factor input fields. We specify the number of tie legs to consider as effective in resisting shear, and the tie size, cover to the ties. And then we start to define the longitudinal bars. So we can tell the program that we want it to begin considering longitudinal bars size 8 and then work its way up to size 14, for instance. I'll skip the bar layout column for just a second and point to the fact that we have a rectangular or square column, and so we'll consider this one to be tied versus spiral. And then I can stretch out the bar layout, and we can read that we have a few options here for bar layouts. One is to place the working steel only on the sides that would resist the moment about the major axis of the column, or we could do bars only on the sides that would represent the minor axis of the column. What makes the most sense for us in a column situation might be to put them on all sides. So I've chosen equal sides for this example, but then there's also the all option at the top, which would consider all of these and give us reports that we could take a look at and make a selection from based on the output. So I don't want to make any changes here. I'll just click cancel. Then we come to exclude concrete elements. Nothing to do here at this point. I've already gone in and excluded everything that I don't want it to have considered for column design or concrete design in general, but notice that we can include or exclude members or shells. The next item is cracking factors. I've already assigned a cracking factor based on the ACI recommendation for columns of 0.7, but this tool is here so that you can assign factors to individual members or to elements. So I'll just click cancel. The RC Design Properties button opens either beam design properties, column, or plate design properties. So we'll look at column. This dialog is just an easy way to combine a predefined criteria that you've set up here with an include or exclude status and a cracking factor, and then assign it to selected entities out in the model. Again, no work for us to do on this one. The RC member input button is convenient in that it opens up a table to show what has been assigned already out in the model. If we just start by looking at the exclusion column, we can see that the majority of everything in this model is excluded except for member 13, which is our one column of interest. It's been assigned a column design criteria, column criteria number 2, and a cracking factor of 0.7. So we can make changes in this table if we want to, but nothing needs to be changed at this point, so we'll just click cancel. We're not working with plates in this model, so we can skip the plate input and move directly to perform concrete design. So in no time at all, this zips through the different reinforcing patterns that we allowed it to try. And if you look, you can see bar sizes 8, 9, 10, 11. There's a reference to a 14 in there. And then there are numbers here that indicate the number of bars on each side, 5, 6, 7, 8. And all the way out here at the edge are clear cover values. So that's a general explanation of what you see in that design output. The next button is concrete design output. We have an option to take a look at an analysis envelope. So here we can select a load combination of interest. We can tell it we're only interested in looking at the selected member in the model. And then for many slices along the height of the column, we can look at the maximum and minimum MZ values. We can look at the absolute value of the shear, and we can see the load combinations that are responsible for producing or providing those results. That's the analysis envelope. We can also come to RC column results, and here we see the nomenclature that we saw before for the selected section, the fact that it has a unity value of 0.951, the responsible load combination, and then the controlling location for that unity ratio, the axial load, the moments about the two axes, the moment magnification factor, and if we stretch the view just a little bit, we can see the calculated beta D value and the CM values. So that's RC column results. The other one that's of interest to us here is shear results. So we can take a look at, again, slices along the height of the column, material properties, stirrup properties, or ties, and the number of legs that are effective, the design shear, the axial load that applies, the stirrup spacing that was found to work, the concrete shear strength, and the controlling load combination. Just to close out concrete design output, we just looked at member shear. The only other items have to do with plates, so those aren't of interest to us in a column. So next we'll move over to flexural interaction. Here we can take a look at the sections again. This shows us the different sections that were tried, and off to the right it explains what each of the parameters means. Then there are options to look at interaction diagrams. These are tables, so not quite as exciting to look at as the last option, which is to see the actual diagrams. So here we have many pages, and if I just click down through them, we can see that the bar pattern changes, and also the interaction diagram is changing as I move through and select different patterns of reinforcing. And that is available to be printed, but for now I'll just click close. And then let's come back to the next button, concrete design diagrams. So we have member envelope diagram and an option for plates. We'll obviously look at members. Here we can see things like member moment envelope, member shear envelope, required flexural reinforcement diagram, and required shear reinforcement diagram. We'll just take a look at a couple of these. Here's the member moment envelope. Be careful when using this dialog, because the way you clarify the view is to select this last one, which is to erase existing diagrams. So what we want to do is show the diagram on, let's show it on the selected members so it's even less to see. And there we have a nice moment envelope. And then if we wanted to take a look at, say, the shear envelope, we could see that. And again, to clarify the view, come back into this diagram mode option and say erase existing diagrams. Okay. The next button is Concrete Design Tools. It has some handy things like a K calculator and a rebar database, and then some beam tools, but we don't need that for the purposes of column design. The last button is the Unity check, and if we click that, we'll see a blue color if the program was able to find an acceptable design, in other words, a ratio of 1 or less. If it wasn't able to find an acceptable design, then it would be colored red. The last thing that I want to show is here in reporting, where if we come over to Print Reinforced Concrete Design Report, we have the option to set it up so that it shows us information for concrete columns, both flexural and shear information, and then say OK. The first page shows us a nice interaction diagram specific to the controlling condition. And then the second page gives us a concrete design envelope, and it gives us a required tie spacing. So hopefully that's a helpful quick tour of what you can do in reinforced concrete column design in EnterCalc 3D.